Good morning, good morning, good morning, everybody. Let's finish this helmet. Package time. Great, now I can do screencasts. Alright guys, let me show you. I'm going to do a screencast. Tell me if you like the screencast, by the way, or if you like me when I point the camera at it. I'm still probably going to do both, but just tell me if you guys like it or not. Also, I'm going to show you, I have all the struts done on the head. I still need to do the opening mechanism and then a locking mechanism down for like it to lock down so it doesn't open up accidentally. Let's see. And then that should be it. Then I got to do the skin and the support. But I think the support on this one is just going to be actual foam because it's so tight tolerance. I think trying to pour silicone for this is probably not a good idea. Maybe. We'll see. Anyway, let me show you. Alright guys, here we are. This is the head. I don't even have you can't see me at all right now. I usually have video, but my camera's not working. Anyway, tell me if you like the screencast. It should be a high resolution for you guys. Here is the thing. How ridiculous. There's me inside of it, so you can see there are the very square eyepieces, which is very much like the Mark 1. I decided to go for something as simple as possible, I think, with this. And the idea is I'm going to put steel all the way around it. Stainless steel, like all the way. It's going to be welded on. So in here you'll see this is Iron Man's very telltale little I don't know what you would call it thing that comes down here, but he always has this part that comes down. So there's that, and then it's going to be very just round shaped. It's not going to be super shapy, which again is like early Mark or like it's like the Mark 1 and like very early Iron Man comics kind of thing. And then the way this is going to work is these are exomuscle anchors in here. So right here and here, those run down to. This one runs down to the torso. This is your sternocleidomastoid muscle, which is that muscle that runs right there on your neck. If you don't know what that muscle is, it's that big muscle that goes like it's that muscle right there on a human. Anyway, it runs down to here, and it's going to pull the head forward and also be able to do a twisting motion. When one is fired, it'll twist so if this one fires, it'll twist the head that way, and then if this one fires, it'll twist the head that way. So it'll allow you to look back and forth as well. And then to counter that motion is going to be a muscle coming down here. And this muscle coming down here also acts as your trapezius essentially and levitates your shoulder. So it also will bring the shoulder girdle up. So this muscle will run down and attach into the superficial transverse joint of the shoulder girdle and lift that up and down like that. So the way this works is this side piece. So this piece right here and this will all be the base piece. They'll be the deep exoskeleton, and they'll be on the head. In addition to the deep part of the visor will also be on the head. So then these side pieces will come in here and here from the side, and then a bolt will go in there and there, and then this up here is going to be the seam, and then like I said, stainless steel will be in between all of this. And then a bolt will go there, a bolt will go there, a bolt will go there. So far we're up to 1, 2, 3, 4 for the other side, 5, 6, 7 bolts to put this on. And then after those come on, then the mandible will come in. So this is the mandible down here, so the chin part will come in, and then a bolt goes there, and then there, from the other side. And so we're up to 9 bolts to put this on. And then lastly, the faceplate will come on, the outer part of the faceplate. They'll be part of this basin here. So like this part will be on, but then this, with the eyepieces all the way down to here, right there, all the way down to that part will then come on, and then there'll be 2 more bolts, right there. So 11 bolts to put this on, 5 separate pieces, and that gets everything real good. These are the muscle anchors in here. And so now what I need to do is I need to get this opening and closing. So here is attempt 1. So this is the first time I tried it. If you hadn't seen this already, I'll just show you real quick. So this is how it's going to open. I still need to do it on the other one, but this comes here. This opens up like that. So that would come up to there about, and then over here, this would spring open like that. There'll be a spring, and then it actually gets hit here as it closes. This gets hit and it's pulled back down, and then it comes back in. So like that. So then what would happen is as this piece rotates down, it starts to interfere with it, like right here, as you can see, and so that would push this then to close like that, and then it would come the rest of the way down, and there'll be just a simple little servo motor that does and controls that. Alright, let me know in the comments if you liked the screencast. It's a little less organic, but it's definitely a lot cleaner looking, I'm sure. Let me know if you like it. So now I need to do the mechanism to open it, and where I'm going to put the servo up top. So there's a mechanism here, there's a mechanism that springs it out. I need to work on both of those, and then how I'm going to plant the servo, and then how it's going to lock down at the base. And then the idea is to have a solenoid open it eventually. I'm going to at least do the mechanism now and maybe add the solenoid secondary, maybe just even do it with my thumb or something like that for the very first couple times I open it, so I can get a solenoid in. Maybe. We'll see. But that's the idea. So I need to get those things done, and then I'm done with the head. And then I need to do some foam and then the skinning on it. Hey guys, I'm in the garage because I'm weird and I keep my fingernail cutters out here. I don't know why I store them out here, but I haven't lost these pair. Probably some of my parents don't steal them. Who knows? Anyway. Or maybe I stole it from them. I don't know. Anyway, Tim was over here earlier. He wanted to do some stick welding. I literally ran one fucking stick because his welder is a lot higher amperage than mine. I think mine's like 25 amps. He was running at 60, and I got a sunburn from it. Isn't that crazy? The helmet is going well. From what I showed you guys earlier, I have the opening mechanism figured out. I will go show you that. And I made a latch mechanism, and then I realized that shit doesn't work because it gets caught as it comes down. So I had to figure out something more clever than that. I don't know what that's going to be yet, but I do want some kind of system for it to lock. I don't know what it's going to be. But I haven't figured it out. I might work today. I'm honestly getting pretty fucking tired. It's 9 o'clock. I'll show you guys definitely the opening mechanism because it's pretty cool. I may do some more work tonight if I'm feeling like it, but I have a feeling I'm probably going to get tired and just want to go to bed. Whatever. I'll tell you guys goodnight though after I show you everything. Alright guys, I'm on the screencast again. I really do want you to tell me if you like this or not. Anyway, here we are. This is the skeleton right here, which I showed you already, so let me show you. Alright, so here we go. This opens up like that, comes up like that. You'll notice that this part right here is curved, and that allows it to get really deep into this right here. So you see how this can reach over. The limiting factor on where it touches is this right here. In fact, you can see it's gone a little too far right there. So that goes in through that. And then this is going to be a bar that comes across and attaches to the other one on the other side. See the other one on the other side right there? So that goes across and attaches there. And what that does is, what that's there for is there's going to be a bar going through there, and that's going to be attached to the servo. I may actually even do 2 servos. I thought about doing that. Or if I don't do it, I'll do it a different way. I don't have the servos in here. I will actually probably buy the servos before I actually make Draft 3, so I can measure them and get exact measurements on them and figure out how I'm going to mount them. I don't know how I'm going to mount them on this, but this is just an offset from that, and I think that's the best way to do it for driving the thing. I could drive directly down the shaft, but the center of the servo will still be lined up with the axis of rotation here, but the bar will be coming down, there'll be another bar coming across, so this would be your point where it comes in. That's the theory anyway. So that comes across there, and then this joint right here, again, there's this swinging thing in here. This comes out, and this will open up via a spring like that, and that brings it out much further. So yeah, that's pretty much how it works right there. And that would be what it looks like in there with my head in it as well. And so if you see if I come straight on like that, you can see I can still definitely see out of it right there. So that's important right there. Oh, and then this is the little thing right here. This thing was going to be to lock it down, and then there was another part that hooked on the other side down in here. The problem is this hits it as it comes in because this sweeps down and then gets caught right here because of the way this mechanism works. The only way to stop that from happening would be to put a servo on this and try to drive this, or maybe somewhere in here. But anyway, that's adds another servo. So I think there's a smarter way to do this. I just don't know what that smarter way is yet, but I'll figure it out and do it tomorrow. And then I am going to actually put skin on this one, and when I say skin, what I mean is the actual like sheet metal. I'm going to model that. It doesn't have to be super accurate because I'm not actually going to print it or do anything off this. I'm going to build it by hand by tamping it out, but I will actually put that on here, so all the parts on there. And to do that is just to give me an idea of actually how I want to build it by hand and to get an idea of what the total weight of this thing will be. I did decide I'm going to go to bed. Yesterday was kind of emotionally taxing, and I'm tired, and it's early, it's like 9, but I get up early, so I'm going to go to bed, I'm going to edit this video, I'm going to pass out, I'm going to come in tomorrow and hit it hard and get that latch mechanism figured out, get the skin done, get the padding done, and then start on the neck. I want to get this. I want to get this done so bad, guys. I moved faster on this than I thought. Like yesterday, I fucking crushed through that thing. I built it all. I just crushed it, which I actually think it's best to build fast, because then you see mistakes and then you just decide to solve them instead of sitting there thinking about it. There's something to be said for thinking about stuff too, but I think the best way to do it is just go for it and really just get after it and put your ideas to the test and figure out what's going to work and what's not going to work. I figured out something really cool today. I didn't get a recording of it, but I called Sterling Edge, which is the company that I'm going to use to have this stuff cut out, to figure out. I was just curious, like, how much it would cost to maybe have it cut in aluminum. And the guy I thought it would be a lot more, but the guy ended up talking to me and saying that because they can cut faster in aluminum, I didn't think I knew you can cut a lot faster with machine tools, like with like a Tormach, with something that's actually physically cutting. I didn't know that was also true for water jet cutting. I just, for whatever, assumed they were going to be the same speed, but because it's so much faster to cut in aluminum, even though it costs more, he says it's actually either similar in cost or cheaper to have it made in aluminum, which is dope as fuck. So we are now going to build this thing in aluminum. It's going to make it much harder to weld, but I talked to Tim today and he's down to weld. He has a spool gun and he says that works okay, and we could probably do it with that, but he's thinking about buying a TIG. He says I'm trying to get him to do it too. I'm a little devil on his shoulder. I'm like, buy it. He says it's like a $3,000 TIG. Tim actually has a job and he works a lot, so he can actually afford that kind of shit. I can't afford that kind of shit. When you do TIG welding, when you do welding on aluminum, you need, I don't really know the exact science of it. They call it AC, and there's something about the fact that it can go back and forth that allows you to break through the oxide layer that is on the outside of the aluminum. You need AC to do that, and so you need a pretty expensive TIG. So we kind of do it with the one he currently has, which is a very cheap TIG. Could definitely do metal with it, but can't do aluminum. But he's thinking about buying a TIG. If you got that TIG, this thing is going to be crazy. And this is a lot better to make it out of aluminum because it'll be a lot lighter. I'll actually be able to move around in it and stuff. And it should be actually just as strong if we use a good, high quality. Well, the tensile strength I looked up today is about 45,000 PSI. And actually, I think the tensile strength of mild steel is closer to 80, so it actually may not be as strong. I might have to reinforce some parts to make it a little stronger, or we could use like an aircraft grade aluminum. That would be the other option. So I might be able to do that and get this a similar strength to steel. It'll still, I'm gonna check really quick, hold on. Okay, so I've been running my calculations and stuff, designing like the anchors and stuff for mild steel, which has about 63 KSI. I think that's for failure, for yield strength, I think, or maybe it's ultimate, I don't know. It's around that. For mild, for 6061, which is marine grade aluminum, the tensile strength, Oliver wants in. Anyway, the tensile strength of 6061 is like 40 KSI, so that's weaker. But if we use aircraft grade aluminum, which is 7075 aluminum, a little bit more expensive, is 73 KSI. So that would work. That would be actually stronger than mild steel, which is what we want. Now, if we used stainless steel, it would be a lot stronger than that even. But stainless steel is expensive. It's going to be harder for them to work. So it's probably the most expensive material we could use. Not cost per pound, because aluminum will actually be more expensive cost per pound, but to actually get it machined is going to be the most expensive material we can use and notoriously difficult to work with. So building out of it is going to be much more challenging. Welding aluminum is no joke, but welding stainless steel is also supposed to be difficult, and hammering out the parts, the rounded parts, to do it, I'm sure is going to be incredibly hard to do with that, but probably won't be that difficult to do with aluminum. And I could probably even use a cheaper aluminum
sheeting to go on there. I think aluminum. I'm pretty damn excited that we're gonna get to use aluminum. And this is not, I'm not sure this is something I'm gonna do, but it is a possibility. Instead of polishing the suit and doing it like the Mark II, which is cool, and I might wanna do it. But what I could do is I could like do a brushed look on the aluminum and then get it anodized. And anodizing, you guys, probably pretty smart people interested in engineering and stuff, you probably know what it is, but I'll tell you anyway. Anodizing is what is done to my titanium glasses, and these are black anodized, but you can do them in lots of different colors. But anodizing is a process via which you actually grow a precious gem on the outside of aluminum oxide, like what laptops are made out of, Apple products are made out of, is a very hard oxide layer that forms on the outside of aluminum and titanium, and it's actually literally what rubies and stuff is. I think ruby is either a titanium oxide or a aluminum oxide. I'm not sure, but precious gems are actually the same shit that's on the outside of laptops. And so anyway, it's kind of an expensive process to have done, but I could do it further down the road when the YouTube channel is making money, or I'm got some more money or whatever, figure it out later. But what it opens up the option to go get that done, which would make a very strong outside layer, which would protect it very well, and I can then get it colored in red and gold. I can make an actual Iron Man looking suit. I didn't want to do that for the Mark I. That wasn't necessarily the initial goal, but it's interesting to have as an option. So I mean, I could anodize it and not even stain it, but if you're gonna anodize it, you know, you could fucking stain it, and you can make it that in red, in gold, anodized aluminum looks real good. It looks really, really good, and that would be pretty fucking cool. I'm not sure I'm gonna do that, but it is an option, which is cool to have. Yeah, so that's cool. That's gonna be cool that we're doing it out of aluminum. Doing it out of aluminum is gonna allow me to walk in this thing so much easier. It's gonna make it so much lighter. It may even open up the option of doing some flight stuff with it. I probably, again, this isn't really going to be built for aerodynamics, so I probably won't be flying vertical, horizontal, but I could at least put some engines on it then and test horizontal, assuming I could get it actuated properly, assuming the muscles are all in the right spot and I can actually get the range of motion functioning as needed with the number of actuators I want. I might just think about it and want to try to add some more just so I can get a more full range of motion. Obviously, the first part is just to get the thing built non-powered. That'll be step one. But then it could maybe open up the option of bringing this suit kind of all the way to flight, which would be kind of fucking nuts. Very cool that aluminum is opened up. As long as we can weld it, I'll just gotta be that devil on Tim's shoulders. Fucking buy it, buy your welder. His welder will probably cost more than I'm gonna put into the entire project. Well, not the entire project. I don't know. I'm rambling now. Aluminum's cool. I'm super glad we're able to do that. You guys are awesome. If you're seeing this video for the first time, because this is a cool video, that the helmet's coming together, things are coming together, the aluminum's cool, please do me a favor and subscribe. It really would help me out, help me grow. If not, I love you bastards that come back and watch this every single day. You guys are awesome. I love you all. You guys have a great, great night.